Hello friends, welcome to BISP Solutions. Myself Ashwin, and today we are going to see the random forest, right? Random forest regression, and it's on a home loan data, right? Home loan data. Just a second. Yeah, it's a home loan data. So now today we are going to see what is a random forest regression, and after that I will show you the process of home loan, that whether that person will get the home loan or not. So that is what we are going to do, right? Just give me a second. Okay, now see here, right? So first of all, let's understand what is random forest technique, right? Now see here, if I show you this image, random forest or random decision trees is a collaborative team of decision making trees that work together to provide a single output. Now see here, if you see on a very simple layman's language, if you see there are three training data instance, then here you will see the model training and the decision tree, and here you will see class A, the final output is class A, here also the final output is class A, and here is the class B. But voting majority comes like prediction output, that is class A. It is just like in another language, if I explain you, it is something like that. For example, we need to take a decision, right? A company, again I am taking you a corporate example. In this corporate example, I am taking it as a company, and that company is just relate this corporate daily life example with random forest regression, right? A company is has decided to open a plant, right? Any plant, cold drink plant, or any manufacturing plant in any city, metro city, right? So now the company is having the board of directors, like 10 to 15 directors are there. It's a very big company. Now every director assess that plant according to his criteria. One is finance expert, one is HR expert, one is the what we say, the logistic expert, right? So there are different criteria. Every director assess that decision based on his own criteria, his own past experience. Finally, every director gives you the output either yes or no. For example, the company owner says that I am opening a plant, I am planning to open a manufacturing plant of cold drink or anything. What's your decisions? So they will give, and based on the majority, the final decision will be taken. Now this is we humans can take decision based on our past history, past background, sorry, experience. Now the same thing we want to be done with the help of machine. Now here random forest regression comes into existence, right? This comes into the role. What the random forest decision tree does, it takes so many small decisions. What the random forest algorithm? Random forest algorithm is a powerful tree learning technique in machine learning. It works by creating number of decision tree during the training phase. Each tree is constructed using a random subset of the data set to measure a random subset of feature in each partition. This randomness introduces variability among individual trees, reduces the risk of overfitting, and improving overall prediction performance. Same thing as I explained you. For example, the owner has taken the decision to open a manufacturing plant, but in that manufacturing plant, now see, in that manufacturing plant there are so many criteria. For example, let's take an example. I am giving you a very simple example. I am opening a plant, my owner is opening a plant of cold drink. Now suppose I am a logistic expert. What I will think? I will think that logistics expert means we have to deploy 2 or 3 vehicles also to take the transportation. Then I will think like this also, that what will be the cost of petrol, costing of the petrol, like, right? Similarly, in other way, suppose I am an HR expert, I am a human resource expert, and I know, so what I will think, okay, we have to deploy some managers also, and what is the population's standard of living, right? What is the population standards of of living, and how many educated people are there, how many people those who are health conscious, so whatever the criteria. So this is called different in the training period, different managers, they take different decisions, and based on that they come to a conclusion that okay, whether we should open this plant or not. Is it clear? So this is, I am giving you the daily life example, corporate example. Same thing is done behind this random forest decision algorithm. So random decision tree is at the time of 80% data that we are taking for the training purpose. So in that training purpose, different subsets are created, and based on that subset the decision is taken. Every look at this again, I am telling you here, each tree is constructed using a random subset of the data. That means subsets are created of that data, and then based on that data it creates a tree set to measure a random subset of features in each partition. In every partition it takes decision. This randomness introduces variability among individual tree, right? So there might be different answers for everything. Now reducing the risk of overfitting and improving overall prediction performance. That's it. See, if you go 40 to 50 years back, when the owner, he was taking the decision by his own, so at that time only one person was taking the decision. Slowly our corporate world improves, and then now there is a board of director. Every director takes decision, and then he submits his report to the owner, and based on that the decision is taken. Same thing is here also. If you see this red color circle, imagine that every tree is taking a decision based on some certain criteria, and decision is taken on the random subsets, right? Subset means, for example, we are having the data of 25,000 rows, and we are having the data that loan eligibility. For example, the bank is having a data of 25,000 customers, and these 25,000 customers, they have, some of them have taken the loan, some of them have not taken the loan, some of are defaulters, right? So this type of data is there, and this is the data based on different criteria, and with the help of different criteria. For example, let's take an example like the car example, right? Car example. Suppose if today the average car price is above 7 lakh rupees, right? So now bank is having the data, like there are so many people, those who are having salary more than 50,000. Now the person who is having more than 50,000, he can easily take the car on EMI, right? So this decision tree will take those data based on the income criteria. Secondly, those those who are having their own house, and their job is like a government job, in that case also that person can take, because he has not he don't have to pay the rent of that, right? Third category is like husband and wife, they both are earning, and not necessarily the salary is very high, but since they both are earning, that means they can take the car. There is a chance that they can apply for loan. So these are called the different criteria. The person who come from farming background, again there is a chance that he might apply for loan. So, but this is, I am just predicting, but this machine learning, this random forest regression is not able to think like human, but it will take the data from the bank. If we feed that data in the format of Excel sheet, and then based on that it decides whether what will be the output. I will explain you it, you will get more clarity on it, right? So now this is how the random forest technique work. Now okay, let me show you this. Now see here, first of all, look at this: gender, married, dependent, education, self-employed. As I already few minutes back I told you that the person who is having more than 50,000 salary, definitely he will take on based on EMI. The person who is postgraduate, there is a chance that he will apply for the loan application. The person who is self-employed, or who the person who is having business, that is also a chance. Then if you see here, credit history, the person whose credit history is good, in that case also, right? The person who is married or unmarried, if the person is married and both the husband wife, they are earning, they are working, definitely there is a chance that they will apply for loan, right? So these are called taking decisions based on the criteria. Actually this machine learning just act like a human. So just take our daily life example and then relate this machine learning with that. Okay, so now as I have explained you with this with the example of board of directors, same thing is here. Now see here, let me show you. First of all, what I have done, I have already prepared the data for you. Okay, I will create a new interactive Python notebook. Okay, new interactive Python notebook, that's it. Now let me take this also as an example, random forest loan. Okay, home loan, random forest home loan. Let me rename it, random forest home loan underscore, right? And then I will save it. Now first of all, what we need the set of libraries. Here NumPandas, as you know, it's a very popular and very common library which will be used to do any type of calculation. No, not calculation, data cleaning and massaging, right? Just give me a second. Just a second. Yeah, okay, now now see here, sklearn random forest classifier. Here we need this sklearn random forest classifier. It's a library that on which is capable of applying this. This is what we are talking about, random forest. sklearn matrices, import, accuracy score, confusion matrix, precision score, all these are the libraries which will be used later on. I will explain you one by one, right? This GraphViz is another library. So let's just wait and watch. Now I am hitting the enter button, all the libraries are being pulled. Okay, okay, now our next task is to read the CSV data. Now let me show you the CSV data also. Here I am going to pull this CSV data. Now look at this. If you see here, gender, male, female, married, yes or no, dependents, how many dependents means how many people are dependent on that one person. Now suppose if you tell me that you have a friend and he is having 5 persons depending on him, so definitely I will imagine that okay, he will not apply for loan. Why? Because 5 persons are there, so definitely he will not apply for loan. If and you also tell me that okay, exactly how much his earning was. So this is how we predict, right? This is just a prediction based on the given data, that's it. Education, if a person is not educated, definitely he will not get the proper source of income. In that case, he will not get the loan. He will not apply for the loan also, right? So self-employed, yes or no, right? Then applicant income, just now I said that applicant income, that is also. So these are called independent variables which already exist, right? Variables which already exist. Now if you see here, applicant income is there, co-applicant income, co-applicant means his wife, co-applicant his partner. Here it is 0, that means he might be a bachelor person. Married, yes, okay, here it is written, look at this, this is 0 and here it is written no, married no, that means he is a bachelor. And many times the partner is housewife, simple housewife, so definitely in that case also here it is written 0. So applicant income and co-applicant means the person which is applying, so that most probably in maximum cases it is his wife, right? Now loan amount. So how much loan amount loan amount is demanded, loan amount term, how many terms are there. Then here you will see credit history. What is the credit history? Credit history means you can say it like that. For example, if I have taken the loan and I have paying the EMIs, paying the monthly installments on proper time, in that case what will happen? The credit history will become good. Then the property area means whether the person lives in city or the village. Okay, and then the loan status, yes or no. Now these people have, this is the historical data, this person has already applied for loan, right? So this is the historical data. Now based on this we will derive. Okay, so now here you have written, okay, data. Okay, now what we are going to do here, now since in our yesterday's session also I told you that linear regression does not work on alphabetical data. Similarly, this random forest regression technique also does not work on alphabetical data. Okay, so for changing that alphabetical data into the number, so we have to denote, we have to give the number for that alphabetical data, right? For example, the data gender, now see here, data is this, data means the data frame, actually it's a data frame, and then data gender. So replace this map gender, map male 1 and female 0. That means wherever you will see this gender, where is that gender? Gender, map male with 1, and look at this, male with 1 and female with 0. Married, similarly data married, map no 0, yes 1. This is self-employed, education. Similarly, we will see property area urban 0, rural 1, and then loan status, that is loan status map n for 0 and y for 1. Okay, so now that is what we have done here. Then I have already written here data columns. Now data dot columns. So data dot now look at this. Now it has given you the index, gender, married, dependents, and education, self-employed, applicant, income, co-applicant, everything, loan status, everything. Now our main target is that, as we have been learning it for the last few days. Again, why this is I'm telling you each every time, that so that you should memorize it. Again, the first of all, data cleaning and massaging, then convert the alphabetical data into the numerical data, then x equal to independent variables and y equal to dependent variables. Dependent variables means the loan status that we need to derive, and independent variable means the data that already exists, right? That is called independent variable, the data that already exists. For example, if I ask you that in the IIT college there are 500 students passed out. Now the data that already exists is whatever the person's education, whatever the person's field, whatever field he has done, the BTech, anything, and what you are going to predict that whether he will get the package of a very high package in a big company. So that is called dependent, because we have to derive that based on the criteria that is already available, based on the data that is already available. So that is why x contains the independent variable, y contains the dependent variable. Okay, I am just hitting the enter. Now x equal to this. Now here you will see the loan status is missing, right? And if I make it as y, now see here only loan status is coming. Okay, so now let's move ahead. Now split the data into now look at this. Split the data into training and test sets. Let's have a quick recap. First of all, getting the data, convert the text data into the numerical data, then split the data. Split the data means separate the data, independent and dependent variable. After that split the data into training and test set. Now we are having the perfect separated data, right? Perfect separated data, and now we are going to fit that data into the x train test. So x train, x test, y train, y test equal to train test split equal to x comma y test size, that is the 20% or 2, it is written 0.2, random state, that is 41, 42. So what this line says, this line says that x train, x test, y train, y test is the variables that they will get the data. Train test split, and train test is x, you are providing the variable x capital and y small, and then remaining 2 are in our hand, like test size, that is 0.2, and random state, that is 42. Then x train dot shape, y train dot y test dot shape, then y train dot shape and y test dot shape. Everything is okay. Then I will hit the enter button. Now look at this. X train shape is 483. This 433 is showing the training data. 11 is the test data. Similarly, x test shape, inside that also training data is 110 and test data is 11. Y train shape, y test shape. Clear? Now what we will do, now see here, RF equal to random forest classifier. First of all, we have to call the random forest classifier. Here is random forest classifier. So RF somewhere it is explained, RF. Okay, no problem. Random forest classifier and rf equal to, okay, already it is taken a new variable here. Rf equal to random forest classifier rf dot fit equal to x train y train. So training data is fitted into this, right? Now here is y predict. Y predict means y prediction. Y prediction equal to rf dot predict x test. Prediction is done on x test, right? So actually you have written here rf equal to rf dot fit x train y train. Now what I need to do, y pred equal to rf dot prediction and y underscore, look at this prediction. Now see here prediction df, pd dot data frame actual value equal to y test, predicted value equal to y pred, and the decision difference, the difference you will take y test minus y prediction. Now see y train, what is this y test? See, actually we have received the data that is already of the history, right? That is the part of history, but now we need to take the decision based on this, right? So that is why we are taking all type of data, all type of possibility. Okay, now prediction, we are going to predict the data, prediction. So pd dot data frame actual value equal to x value, actual value, then the predicted value, and then the difference. Okay, so I am going to look at this, actual value 1, predicted value 1, and then the difference is 0. That means difference is not much, right? Predicted value is, predicted value is this and the difference is this. So if you see, it is not much difference. Okay, now we are going to take down the accuracy. Now see, this machine learning, this random forest regression technique is showing you that it is 76% perfect. Now one more step that we need to take from sklearn, right? From sklearn import tree dot plot tree rf dot estimators 0. Now I will show you, look at this. Right, the Gini, that is the error, right? That is the difference between. So look at this, 97, there is estimators here, 97, 91, 94. So there is not much difference in this, right? Look at this. This is the final output. So the data, whatever we have given, it is completed inside this, and here the prediction is taken out. Okay, so now this is how the prediction is taken, and you will see this is the final output. So this is same as we have understood in our daily life corporate example, right? So same thing is done here. So guys, let's have a quick recap once again. First of all, taking the data, and what exactly what we are doing, we are just predicting that whether the data eligibility, that person is eligible of getting the loan, or whether that person is applying for loan or not. That's it. Okay, so now here you will see the data. First of all, the important libraries are pulled out, and then we take the CSV of from that concerned person, whosoever is responsible for that. Then we will map, we will not make it 0, we will make we will go each step by step, and then we will make it 1 and 0, right? So there will be no confusion. Then the data is coming here. Now if you see here, data here, this is the data. Now data, you will see the columns. Now splitting the data into the two parts, that is x is independent variable, y is dependent. So y on y only one thing is there, that is loan status. Okay, so this is what you have to derive. X is this and y is this. Okay, now we have the train test split function, and based on that we will put the data inside this train test split. And then after that, here you will see the test and train test split, and then we will put the shape also. We will see the shape, then you will see rf.fit, right? And then we will fit the data inside it. Then we will get the prediction also, right? Then based on that prediction, we will get the predicted value and the difference also. So here difference is showing. Then we will get the accuracy also, the accuracy score. So accuracy is 76%. Then based on that we have applied the formula, and then the final is this. Here the final is this. So based on that the decisions are taken, right? So guys, I recommend you to watch this video twice, thrice, and if you don't get clear, then you can easily connect to me, right? So guys, watch this video again and again, and then if you have any error issue, then you can put it into the comment box, right? And in our next session we will meet with some other important topics. Okay, so thank you guys. Those who are not familiar with my channel, they can subscribe the channel. Okay, so thank you guys. Today we are concluding here only, and tomorrow we will meet with some other important topics.